Hello everyone, Karan Yang here. Today we're looking at a very interesting algorithm problems, which is Tucson. It is the very first problems available on LeetCode. So let's get started. The problem is we get an array of integers and we get an integer as target. We want to find two numbers in the array which add up as the target. And we want to return the indexes of these two numbers. Um, for each of the input, we have exactly one solution, so um, we we won't be use the same element twice, and the answer that we return can be in any order. So let's look at the examples. This is the input numbers 2, 7, 11, and 15, and we're looking at target 9. And if you look at the array, the first element 2 and the second element 7, they add up as 9. So the answer is the indexes of them, which is 0 and 1. For the example 2, we want the target 6, and 2 plus 4 is 6, so we return 1 and 2. And for example 3, we return 0 and 1 because 3 adds 3 equals to 6. Okay, so how can we solve this? The first um, approach that we can use is very straightforward. We can just brute force it. We look at all the pairs available in this array and see if any of the pair they add up as the target, then we return the indexes. If there's no uh, pairs adding up as 9, like the target, then we basically throw or return none. I'm not sure how it's going to judge it. Um, so yeah, so only one answer exists, so there might not be on like no outputs case. So let's try to implement that. Um, cool. So the answer that we want to return is an int array, and size of the array should be exactly 2 because we're looking at two numbers, and we just write two for loops. So if numbers I plus numbers j equals to target, then yeah, the first index should be I, and the second index should be j, right? So we return the answer, right? So I'm not sure if there's no answer how what is expected. Let's just return the answer. So run code. It's an error. Okay, this is not n. It should be numbers dot length. Okay, so we passed the test case, the one of the test case. So let's submit it. Okay, succeeded. Um, it's faster than around 20% of Java submissions. But yeah, at least we solve it. So this is a brute force solution. If you look at the for loops, we basically um, find each of the pairs, and in terms of time complexity, um, it's O n square. Okay, and if you want to see space complexity, we are actually not using any storage, so the space complexity is O1. That is the brute force solution. Um, okay, can we improve it? Is it possible that we can do ON? Um, let's see. Okay, so how can we just loop it once? So if we look at the first number, which is 2, we don't have any information of the remaining items, so we couldn't get the answer. But if we look at 7, uh, after we're looking at 2, we might be able to find the answer because we already visited 2 and we know 2 is there. So we basically know 2 and 7 together, they are the answer, right? So what if we have a storage sitting aside which have the 2 there, and if we can have an O1 lookup time for that storage, then we basically can achieve um, ON time complexity. Um, so we are not only we're not only looking at the the value, the number which is 2. We also care about the index of the value. So we also want to save the index of the number in our storage. So what is the best data structure that we can use to save such information is HashMap. So what we can do is we can have a HashMap um, with integer as key and value pair, right? And what is the key and what is the value? The key should be the number, and the value should be the index of that number in the array, right? So let's say here, okay. Um, and then we start looping through the array. Numbers length I plus plus. Okay. So if we visit the first number 2, um, then we are looking at what we really want is we want to find the complement of that number. So what we are looking at is um, complement equals to target minus numbers I. That's if we already have this value available in our hash map, then we basically find an answer, right? So let's see. If in our uh, hash map we already have complement there as a key, then we basically found the answer because you know uh, the complement is the first element and the the I is the second element. right? So let's define the answer. Right. So answer 0 equals to, now we get the index of the complement value, right? And the second index is I, right? And then we return answer. What if the complement is not available in the hash map? Then that's fine. We can just put the current element into our map. So it should be number index mapping put. Okay. Numbers I and index is I, right? So if we loop through all the elements and still don't find any pairs, then we basically failed to find an answer, and we just return the empty answer. Let's see, run code. Okay, it works. Let's submit it. Okay, this time it's way faster. It's 5 milliseconds. Compared with the first one, which is brute force, it speed up a lot. And yeah, for this solution, if you want to know the time complexity, we basically loop this whole array once. So time complexity is on, and the space complexity, because we use the hash map, right? Then if we end up not finding an answer, then we basically saved all the elements in the array into the hash map, so the space complexity is on. So we basically trade space to decrease the runtime. Yeah, that's this problem. Very interesting. Hope you enjoy it. I'll see you on the next problem.